expression we are given a quadratic equation in x and we are told that x is real. That is, the quadratic equation has real roots and we are asked to find out which of the following is necessarily true. If you are given a quadratic equation which is of the form ax square plus bx plus c is equal to 0, and if you are told that the roots of this quadratic equation are real, then it would imply that the discriminant is greater than or equal to 0. What is the discriminant? It is equal to b square minus 4ac, where b is the coefficient of x, a is the coefficient of x square and c is the constant term. So in this particular case, again the discriminant of the given quadratic equation has to be greater than or equal to 0. What that would imply is that 2m into n plus p whole square, so that is equal to 4m square into n plus p whole square, has to be greater than or equal to 4 times the coefficient of x square, which is m square plus n square, into the constant term, which is m square plus p square. This has to be necessarily valid. We can expand both the sides. We can first cancel 4 on both the sides. So the left hand side is equal to m square into n square plus p square plus 2pn is greater than or equal to m to the power 4 plus m square n square plus m square p square plus p square n square. This is just expanding the brackets on both the sides. We can cancel the common terms. On the left hand side we will have m square n square plus m square p square plus 2m square pn. This we are told is greater than or equal to m to the power 4 plus m square n square plus m square p square plus p square n square. As we have discussed earlier, we can cancel m square n square on both sides, we can cancel m square p square on both sides, and we can bring this term to the left hand side. This would imply that m to the power 4 minus 2m square pn plus p square n square is less than or equal to 0. But what exactly is this? If you observe closely, this is basically equal to m square minus pn whole square. So we are told that m square minus pn whole square is less than or equal to 0. This is valid if and only if m square minus pn is equal to 0, because this is a perfect square and every perfect square is greater than or equal to 0. So if a term is both greater than or equal to 0 and less than or equal to 0, it would imply that that term is actually equal to 0. So m square minus pn has to equal 0, or the value of m square is equal to pn. So the correct answer is option B.